Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P16BB, for the Honda Accord models from 2008 to 2012 indicates an issue specifically related to the alternator B terminal circuit exhibiting low voltage. This code highlights concerns in the electrical charging system, where the alternator is not providing sufficient voltage. The alternator is a critical component responsible for generating electrical power to charge the battery and supply power to various electrical systems while the engine runs. Its location is generally found near the engine compartment on the driver's side, mounted to the engine block. The structural integrity of electrical connections is vital, as loose or corroded terminals can lead to inconsistent voltage readings, triggering this DTC. Before diving into troubleshooting, it is essential to gather all freeze frame data and snapshots for future reference. This information helps understand prior vehicle conditions that may have contributed to the fault. The alternator plays a crucial role in maintaining the electrical system of the Honda Accord by generating electrical energy needed to power the vehicle and charge the battery. The components affected by DTC P16BB include the alternator itself, the battery, and the circuitry connected to them. This DTC suggests the B terminal circuit may be malfunctioning due to low voltage, adversely affecting performance. The alternator is typically located on the front portion of the engine and is connected to various harnesses and the underhood fuse/relay box. This positioning makes it essential for diagnostics, as any issues may lead to significant electrical disturbances within the vehicle's various systems. The alternator's health ensures the smooth operation of electronic components, including lights and climate control systems, making the proper functioning of its terminal circuits vital for overall vehicle performance. There are several potential causes for the DTC P16BB. First, poor connections or loose terminals can disrupt the flow of electrical current from the alternator to the battery and other electronics. Such issues are commonly found at critical junctions like the alternator and the underhood fuse relay box, where vibrational forces may cause connections to loosen over time. Second, an open in the wiring harness, specifically between the alternator and fuse relay box, can lead to compromised connectivity, resulting in low voltage readings. Inspecting wire conditions and continuity in this section is fundamental to resolving the code. Third, a faulty alternator may itself be incapable of generating sufficient voltage, mandating its replacement if found defective during testing. Diagnosing the cause accurately will ensure the resolution of not just the code, but potentially prevent further electrical issues down the line. When experiencing the DTC P16BB, several symptoms could manifest as a result of the low voltage condition. Users may notice electrical system malfunctions, which can range from malfunctioning interior lights to unresponsive electronic features. Dimming headlights is a common indicator, as insufficient voltage directly influences the ability of lights and other accessories to operate correctly. Moreover, the vehicle may illuminate warning indicators on the dashboard, particularly the battery warning light, suggesting that there are issues with the charging system. Other symptoms can include difficulty starting the engine, erratic behavior in various electrical components, and a general lack of power, which significantly impacts driving experience. Buffering symptoms can even compound if not addressed, leading to further battery drainage and possibly needing a premature battery replacement. The first step in troubleshooting DTC P16BB involves ensuring that all preliminary data is captured accurately. Begin by turning the ignition switch to the on-to position while ensuring not to start the engine. During this action, it's important to record all freeze data available through the vehicle's onboard diagnostic (OBD) system. Freeze frame data helps represent the vehicle's conditions at the time of the fault, allowing a technician to gauge how the vehicle operated when the DTC was triggered. Furthermore, reviewing general troubleshooting information is essential, as it provides guidelines for effective diagnosis and may highlight aspects that may not be immediately evident. This foundational step sets the tone for the rest of the diagnostic process and aids in accurate field decisions. For the second step, utilize the Honda Diagnostic System (HDS) to clear the previously recorded diagnostic trouble codes. By clearing the codes, we will effectively reset any stored faults in the Engine Control Module (ECM) or Powertrain Control Module (PCM) prior to further testing. After clearing the codes, proceed to start the engine, making sure to observe any immediate changes in behavior or warning lights on the dashboard. This process prepares the system for the next crucial diagnostic testing phase, as it allows the technician to assess the current electrical performance under differing operational conditions. Each subsequent check will be compared to the recorded performance to determine if the error persists or if it was indeed a transient issue. In the third troubleshooting step, the technician will check the vehicle under specific conditions to assess the integrity of the electrical system more effectively. This testing condition calls for the air conditioning (AC) to be engaged and temperature controls set to maximum cooling, simulating significant load on the electrical system. The blower fan should also be set to maximum speed, contributing to the total draw on the system. Additionally, turning on the headlights at high beam and engaging the rear window defogger are essential steps. These combined actions create an environment for the alternator to function under simulated high demand, crucial for identifying any weaknesses in voltage output or electrical connections. The performance during this load test will provide crucial insights into whether the alternator and wiring maintain adequate voltage levels or if issues arise. Once the engine is started and the electrical loads established, the next step is to maintain the engine speed at 2000 RPM for 1 minute. This action replicates a consistent operating scenario to observe how the system responds under load. It's crucial to keep the transmission in either park, AT, or neutral, MT, to ensure stable conditions. Following this minute-long hold, the next course of action involves checking for any pending or confirmed DTCs using the Honda Diagnostic System (HDS). If the DTC P16BB is indicated again, it confirms that the underlying issue has not been resolved and further troubleshooting is warranted. If the DTC does not show, it may imply an intermittent fault, therefore requiring additional checks for poor connections or loose terminals that may have sporadically affected voltage transmission. Upon confirming that DTC P16BB remains present, it's time for rigorous physical inspection of critical wiring connections. Start by examining the connections and terminals at the alternator for signs of corrosion, looseness, or damage. A secure connection is imperative, as any disruption can lead to incorrect voltage transmission. Next, the underhood fuse relay box should be examined, particularly the B line, which channels power to the alternator. Any poor connections here can further propagate issues within the electrical system. This evaluation process is central to identifying any visible faults, and if found, necessary repairs should be made before continuing with further diagnostic steps. Should the connections pass this inspection, we proceed to check the integrity of the wiring harness between the alternator and the fuse box. The sixth troubleshooting step focuses on investigating the wiring integrity between the alternator and the fuse relay box. By checking for any opens in the wiring harness, we ensure there are no breaks leading to interruptions in electrical flow. This involves visually inspecting the harness and potentially conducting continuity tests to verify the complete circuit's health. Any identified wire damage or breaks will directly affect the alternator's ability to supply voltage and should be repaired before proceeding. If the wiring continuity test yields a successful result, it indicates that the harness is likely functional and should not impede voltage output. Conversely, any open circuits found would necessitate focused repair efforts to restore the circuit path's integrity before moving on. After assessing the wiring, we now return to resetting the engine control module, ECM, or powertrain control module, PCM, to evict any persisted codes. Turn the ignition switch to the on or on position to pave the way for another troubleshooting phase. Utilize the Honda Diagnostic System, HDS, once again to reset the ECM PCM settings, which restores factory settings post-repair or inspection. Following this reset, it's necessary to perform the ECM PCM idle learn procedure, a process that allows the module to register all new data regarding the vehicle's idle settings and various systems that may have had adjustments made. Restarting the engine after this step readies the system for thorough checks under the same electrical load conditions while maximizing temperature control and other insituating requirements. In this step, the technician will echo previous tests to determine whether the issues have been resolved. The engine should be started and allowed to reach operating temperature with all previously defined electrical loads active, including maximum AC, blower speed, headlights on high beam, and rear window defogger. Hook up the HDS once more, checking for pending or confirmed DTCs. Holding the engine at 2000 RPM during this test will provide the right conditions to evaluate whether the alternator can adequately supply voltage. If DTC P16BB recurs, it signifies persistent issues requiring attention, likely indicating that the alternator itself may be faulty, thereby necessitating further checks or replacement. Conversely, if the code does not return, the troubleshooting process may be concluded. Final repair verification is critical to ensure that the issues leading to DTC P16BB have been effectively resolved. Begin by checking the overall performance of the electrical system, making sure that all components function as intended under normal operating conditions. This can involve testing systems such as lighting, AC performance, and other electrical components that were symptomatic prior to repair. Post-repair, the vehicle should be re-evaluated with the Honda Diagnostic System, HDS, to confirm that no new or recurring diagnostic trouble codes are present. Having no error codes signifies the resolution of the original problem, allowing the owner to return to normal driving without ongoing electrical concerns. Maintaining the integrity of the electrical system ensures reliability and supports long-term vehicle usage. Preventive maintenance is a proactive approach aimed at minimizing future failures related to DTC P16BB. Regularly inspecting electrical connections, particularly at high-traffic areas like the alternator and under-hood fuse boxes, can preemptively catch corrosion, dirt, or looseness that might develop over time. Timely battery performance checks can ensure that the battery is in optimal condition, as an underperforming battery may also put excess strain on the alternator. Additionally, engaging in routine inspections of the alternator's health will help in ensuring that it delivers adequate voltage without interruption. Keeping the electrical system clean and linking all wiring securely can help prolong the life of these components while decreasing the likelihood of future DTC occurrences. Taking these preventive measures will support a reliable and efficient vehicle experience. In summary, DTC P16BB signals low voltage in the alternator B terminal circuit within the Honda Accord models from 2008 to 2012. This code reveals potential underlying issues with electrical connections, wiring integrity, or a defective alternator itself. Following the systematic troubleshooting steps, starting with the recording of freeze data, clearing DTCs, and progressively conducting detailed inspections, leads towards effectively resolving the issue. It is essential to conduct thorough checks of vital connections as well as the wiring to affirm that all components work harmoniously. Finally, adopting preventive maintenance measures ensures the longevity and performance of the electrical system. By adhering to these steps and understanding the importance of each component, vehicle owners and technicians can ensure an optimized driving experience. Please like and subscribe to the channel. See you next time.